healthcare sector lead for Siemens Smart Infrastructure. Today I'm going to talk you through a little bit around, I suppose, the approach to smart hospitals from a patient and staff experience point of view and a sustainability point of view as well. So we're going to cover at a very high level some of the outcomes we look to try and achieve through some technology and IoT technology effectively. So before I do that, I just kind of want to set the scenes really, talk about some of the market trends, some of the KPIs that we're seeing in the market, and really what the hospitals are facing in a kind of a perfect storm that we see at the moment. So some of the factors affecting this, we sort of project, or the WHO project, by 2030 there's going to be a global shortage of healthcare workers of 18 million by 2030, obviously putting pressure on the system. Patients' expectations are increasing. We all want better care, we all want faster care, we all want more digitally enabled care as well. 33% of hospitals, this is not just UK, this is globally by the way, are either reporting an operating loss or a budget shortfall. And we're all living longer, so we project by 2030 there'll be 3 times as many people aged 80 and over. And then adding to that the sustainability element as well. So obviously we know the UK NHS is trying to achieve net carbon zero by 2040, but globally the healthcare system is responsible for 5% of all CO2 emissions. So across the industry, we kind of we observe 2 approaches to how smart hospitals are envisaged and delivered, I suppose. So one is the traditional approach, just purely focusing around the construction, the efficiency and the security from a building technology perspective. And then in the operational phase, there is how do we improve hospital operations, how do we look at staff performance, improving patient experience, and how do we protect people and assets as well. So the way we kind of approach a smart hospital is kind of combine them 2 approaches to look at both the hospital building and the hospital operations as well. So both of them kind of work hand in hand. So that gives us the ability to look at a number of things. So we look at, just working around the screen here, sort of very much early stages, 7% reduction in the shorter project cycle and the design time, construction costs as well. From an operation and sustainability perspective, we look at a decarbonisation strategy for existing buildings, but also new build as well. How do we make sure new buildings are net carbon zero? Resource efficiency and energy efficiency around operations, and obviously a resilient power system is quite critical to all of that in the design phase. Cybersecurity is a very hot topic as well globally. Average attack in the USA costs the healthcare system $5 million. Now it's hard to equate that to the UK because it's not a revenue-driven business effectively. So the tangible, the cost will be quite tangible and significant for the NHS in the UK. So all these are driving towards how do we use technology to increase satisfaction and efficiency drivers as well. So from a hospital operations point of view, we look at outcomes as to how do we increase patient experience, how do we increase staff satisfaction levels, which leads to 2 things. It kind of leads to staff attraction and staff retention as well. Through some of the surveys we've done, we note that hospital staff spend an average of 72 minutes looking for equipment or looking for colleagues per 8-hour shift. So we look to say, well, actually, from an operations point of view and a life cycle point of view, how can we increase or how can we improve on that? An increase in patient outcomes as well. One of the top 5 factors that some of the surveys that's been done is actually controlling their own environment within a single occupancy room, for example. Patients say they want control of their own environment. They want to go to control the heating, the lighting, the ventilation, and et cetera, to give them that more sort of home-based environment. And then how do we protect people and assets as well? So how do we use technology to prevent theft of equipment or equipment going lost? How do we use technology to ensure people's safety and security, and also give them uninterrupted operations? That's slow. So we found that typically up to 70% of that fail. So when people we do a lot of work in the Far East, in Europe as well. And historically, a lot of the smart hospital concepts have failed because of, and the reason for that is typically the complex nature of multitude of systems that are involved in a smart hospital. So I suppose when you look at a conventional hospital to a smart hospital, they've all got the same system. So they've all got security systems, they've all got CT systems, they've all got incumbent systems. The key to that and how you make them smart is trying to look at how you integrate all them facilities together. So we've kind of identified strategic objects for hospitals that increase performance, decrease cost and risk. And we focus on outcomes really. So driving around them outcomes is how do we improve patient outcomes and experience? How do we drive staff efficiency? How do we make the hospital facilities more energy efficient and more power resilient? How do we ensure that cybersecurity is up there at the top of the agenda? Quite often it's probably not, in my experience. How do we protect assets and how do we reduce construction time and construction costs? Sorry. So all that kind of leads me to the digital piece. And there's an awful lot of phrases I find in the marketplace around digital, what digital means, but a lot of buzzwords. You speak to people about digital twin, you'll ask them what digital twin is. You ask 100 people, you'll get 100 different answers. So, we try to combine all that together and say, well, actually, where do you start with this? The smart hospital system has a multiple pool of systems that need to be combined and work together as one effectively to become a smart hospital. So we start off by really integration, and this is just a high-level architecture of a smart hospital solution. So just to give you an idea and just to walk you through what this sort of smart buildings platform looks like in a way, across the bottom here, you've got all the field devices which generate the raw data. So stuff like lighting and electrical systems, CTV, the building twin, all the power distribution. So all the field and all the grid edge devices are obviously out in the field. To do that, we connect them all into an IoT platform or a smart buildings platform effectively. And what that does is that aggregates all the data, it unifies all the data so that all the systems can work together across one common platform effectively. I think historically you'll find, or certainly an experience historically, a lot of the systems operate independently across the system, so nothing talks to each other. And this is how we start to sort of use the different systems to drive different use cases and different outcomes. All them then connect up into a data lake or a common data environment through open APIs, which then gives us the ability then to take that next level of a digitalization layer into applications and services, and that can be software as a service type approach, which we're seeing happening quite a bit now in the financial markets and in the education market as well. We're starting to see customers come to us and say, well, I don't particularly want to buy it, I just want to buy the service. So I want a bit like the Sky subscription box. Effectively, you'll pay a monthly subscription for occupancy detection or real-time location services or whatever that might be. So we're starting to see a shift in certain markets. How far the healthcare market's got to go to catch up to that, that's what remains to be seen. And then obviously you've got all the digital remote enablement as well, and then the system needs to be, as we sort of talked about before, open and interoperable and be able to communicate with anybody's system effectively. So I think vendor lock-in has been the thing of the past. I think companies are now shifting away from you have our system or you don't have our system approach into a more open and interoperable, and that's the way the smart buildings platform should operate. Once you've got that sort of system put together, and that's a journey that doesn't happen overnight. That takes quite a number of time. Obviously, there's the cybersecurity strategy around that as well to make sure that the system is cyber secure to the nth degree. And then from that, we can start driving use cases to sort of drive the efficiency we talked about earlier. So we look at, across the top there, you can see real-time location services and the use of that to help staff search for equipment or search for colleagues. Treatment status notifications, patient information systems, all them build into the system to generate efficiencies in both staff and building effectively. We're just going to look a little bit closer into some of the some of the applications that really at that top end layer that helps the patient and helps staff sort of increase. Let me zoom this on. So this is looking at a patient arriving in hospital. So through a single application, really linked into that platform, patients should be able to arrive at the hospital, digitally check in. They should be able to pre-book car parking and pay for car parking through a single application. That application should also give them wayfinding from where they are in the facility to where they need to be. But also it should notify staff members that that particular patient has arrived as well. So it kind of makes the whole process a little bit more seamless. You've got less people asking for directions, less people sort of wandering around, and you can see exactly where they are in the facility. From a patient settling in point of view, we talked about patients being able to control their own environment. So again, through intelligent BMS systems linked to the same platform, through the application, patients can control their own room temperature, their own humidity, their own lighting levels, and control blinds if you've got automated blinds. Again, all through some single application. And again, that makes a patient feel a little bit more at home. It kind of gives them that control of their own environment. Also creates that positive healing environment as well. So, yeah, just on to the next one. Sorry. So, just I suppose switching to the other side now, we're looking at it from a staff's perspective. Again, through the same application, staff can actually get notifications that that patient's arrived, and this looks at actually what equipment or what processes is that patient going to go through, what's needed, so they can now start to prepare for that particular patient's procedure. And it gives them real-time information and real-time data as to what's needed for that patient. In this case, we're looking at a mechanically operated bed. So the patient is, or the staff member, sorry, is looking for a mechanically operated bed. The staff member will actually just put that into the system, click on navigate effectively, and that will take them through real-time location services, take them straight to that asset. So there's a saving there in staff time by being able to just locate assets and locate colleagues and patients as well through the same application. So, but also through geofencing, we can also tag that asset to say, well, if it leaves a particular boundary, if it leaves a particular area, we raise an alarm, we alertify security. So that drives both CapEx and OpEx savings in being able to prevent loss and theft of equipment effectively as well. So it's all based around that CapEx and OpEx. So just ensuring uninterrupted treatment, again, through the same application. Staff members may come to a device and find it's faulty. That same application should give them the ability to raise a works order, which links direct to the FM team. Sorry. And then put that piece of equipment out of service effectively. Again, all automated through the backbone of the system. And it also gives you that complete sort of maintenance log, so you can see there when it was last cleaned, when it was last maintained, and hours since last used effectively. So all this kind of drives towards that more efficient process. And smart energy management from an FM perspective, really, obviously, we all know the energy consumption in hospitals. We're trying to drive efficiencies. We're trying to drive that as well as part of a decarbonisation strategy. It needs to be a resilient power supply. So again, through that single system, through the single buildings platform or the smart buildings platform, depending on user access and authorization levels, it gives the FM team complete overview of today's consumption, yesterday's consumption, last week's, and we can start to look at projecting in the future as well. So we can look at, historically, you've got the data of what you've been using over the past 6 to 3 months, whatever the period may be. So you can then start to tie that into your future projections for energy demand, but also future projections for CO2 emissions as well. So we can start to project, well, historically, by making different interventions, we can start to look at how to reduce CO2 levels as well. So again, all through the same sort of application and platform. And if you make that intelligent enough, we can start to look at peak load management as well. So if you've got quite scarce in the healthcare sector at the moment, but certainly battery storage is up and coming in a lot of other sectors. how do you utilize that battery storage system during the peak hours to take away your peak demand? Just sort of back to the patient a little bit, sort of digitalization at the bedside. So we're all quite familiar with patient information systems, quite traditional, quite focused on the patient being able to entertain themselves. So trying to drive better outcomes with that is linking that again back to the smart hospitals platform to give the patient that better experience. They can control their environment through a device. But also you can link that into the treatment plans. You can also give them treatments of notifications, so if they've got a treatment today at 10 o'clock or 2:30 this afternoon, they will see notifications on the device telling them exactly where that treatment is, when it's planned for, if it's running on schedule or if it's running behind. But also by, let's make it a little bit more intelligent, scan a QR code, and that gives them the wayfinding application as well on the mobile device. So they've automatically got that wayfinding capability to the treatment. Also, systems out there should be able to, again, trying to increase that patient experience, let the user sign into their own Netflix account or their own Amazon Prime account or whatever the streaming service may be they're using, and also be able to book meals on it and a host of other things as well. So, this should be a bit more of a, not so much entertainment, but an information system as well. So, excuse me. And then from an employee's point of view, there's a couple of things there, really. Access to medical records at the bedside as well. I think that's becoming quite key in the sector. There's a lot of, we're seeing that quite widely across the EU at the moment, and that the expectation is that the switching staff and nursing staff should have access to medical records at the bedside. So the system should be able to do that at the bedside, and make the nurse call system a little bit more intelligent as well. So rather than just having a button that calls a nurse, let's make that a little bit more intelligent, so the patient can request a glass of water, or I need some painkillers, or I need some assistance. So again, we're kind of driving them efficiencies in a staff point of view, because the nurses at the station will see that patient A needs a glass of water and they can delegate that, rather than making 2 or 3 trips to find out what the patient needs and then servicing that needs. But also be able to have video consultations at the bedside as well. So, consultants and doctors, again, trying to drive efficiency from a staff point of view. Just moving on to efficiency and sustainability, plan check. Just starting to look at really just digging a little bit deeper into some of them use cases and technology, and how do what are the enablers, and what field devices, what platform layers, and how that all sort of links together to create that particular use case and drive efficiency. So you see here a typical example, helping staff track and locate medical equipment and save valuable time for patient care. So the less time they spend looking for equipment or looking for colleagues, it gives them more time to do the primary role of caring for the patient. So you see here that, typically you need a smart lighting system with some indoor sensors, some IoT sensors effectively. Medical equipment should be tagged so that you've got real-time location of where that medical device, where that piece of equipment is in the building. And you see some of the name beside the blue GPS ward manager, and then some kind of out of the box real-time location asset tracking type software as well. So again, all this links back to that sort of common platform. So we talked about before, sort of trying to drive CapEx and OpEx savings as well. So we can notify staff members through the same device when a particular equipment leaves that designated area. So that could be somebody wandering off with an infusion pump, or any kind of asset that's mobile effectively. So we're driving efficiency, and we're looking at how do you, during the operational phase, say CapEx and OpEx spending. Reducing HVAC consumption as well. So again, through real-time monitoring of HVAC equipment, the system should be intelligent enough to detect when that system is using more energy than it should be doing, and identify opportunities to reduce consumption. So again, you need a bit more of a intelligent HVAC system around that, and then there's some building automation to identify that, and we start to look at predictive and preventative maintenance rather than reactive. So, and then the apps and services sit across the top of that. You've got out of the box software as a service type applications to service that. Controlling energy use, sort of linked to location data of mechanical systems. So again, we're looking here at energy use by occupancy effectively. So if an area is not being used, then why heat it, why light it? So again, through a smart lighting system with integrated IoT sensors, we can take that sort of motion control a little bit further and start to look at, well, actually, we drive efficiencies in both energy savings and FM savings as well to a degree. So if a ward or a meeting room's not particularly being used during the day, let's scale back the HVAC, let's scale back, turn off the lights effectively as well. But also you can feed that into your FM cleaning routine as well. So actually, if a meeting room's not been used today, then why clean it? But if you haven't got the data to say it's not been used, typically the FF team will just go in and clean it anyway. So again, we can start to look at more efficiencies through resource there as well. So again, through the smart buildings platform, sort of identifying opportunities to reduce consumption through monitoring and meeting. Obviously, trying to achieve KPIs for the hospital across all utilities really. So again, we start to look at integrating more and more systems onto a common platform, from an automation, HVAC, electrical lighting, and any asset really that is consuming electricity across the facility, integrating that, then field devices into that common platform layer, and having that sort of 24 hours, 7 days a week monitoring of them assets and trying to drive efficiencies through that. CO2 reporting as well, touched on this a little bit earlier. So obviously CO2 reporting is up there. How do you predict what your CO2 emissions are going to be next week or next month or next year? So you can only do that really through historical data. So again, through doing single interventions, you can start to model that in a platform. So if you've got a traditional hospital system with a grid intake, diesel generators, but you actually want to start to think about, well, I'm going to switch out and put some ground source heat pump in or add some solar. What does that look like and what impact does that have on my CO2 emissions? If your smart hospital or your smart buildings platform is intelligent enough to do that, you can start to model that in the platform. Start to say, well, actually, this intervention will have this output and this effect. But working right the way through from both CO2 emissions to energy savings and ultimately OPEX savings as well. Again, trying to coming back to the peak load management. So again, your system should really be intelligent enough and optimized enough to be able to understand that load, kind of predict the load of the building and the load of the system, and be able to react to that in the future. So you'll start to, over time, build up historical trends of what load's being used when. And the system really should be that, intelligent enough to sort of predict that and make sure that battery systems are fully charged for the next peak demand, so that the system becomes a little bit more, I think it said self-aware then, but it becomes a little bit more intelligent for, being able to predict when the peak demands are going to be and be able to optimize the system to cope with that. So it's easier said than done. We're sort of looking at, we've touched on this before, and this just kind of summarizes what does that smart buildings platform look like, and how does it link all together? So talked about, so you've got the connected and grid edge systems. So you can see that the field devices here across the bottom, right the way through to driving outcomes and experience, performance and sustainability. But also, that platform needs to be interoperable and open protocol as well, so that you can connect any asset to it effectively. So you've got one platform, and I hate the phrase, a single pane of glass to view all assets across the facility, rather than a traditional EMS system just looking at HVAC and security, or a different system for security and fire, etc. The world is kind of changing towards that single integrated platform for all systems. And really, just to summarise that bit, the three requirements there, kind of working hand in hand, is sort of smart medical infrastructure, smart operational technology, and smart connected IT infrastructure as well. So I'm just going to move on to sort of energy savings. I know that was a question from one of the members around energy savings with MRI scanners. So I'm just going to touch on this a little bit, and then we can sort of close for a Q&A session. So I've had some conversations with our healthcare team, and there's a number of factors around how do you save energy, how do you reduce CO2 emissions from an MRI scanner. So the most common one is turn it off. You know, you never get any more savings than turning it off during non-working hours. But again, coming back to the smart buildings platform, can we link that to a patient booking system and understand the scheduling of patients that are going through that scanner that day, so the system is automatically turned on at a 5-10 minute startup time before that first patient arrives. So, you know, if we've got systems that communicate with each other and can talk to each other, we can make the system intelligent enough to shut that scanner down during scans or in between scans or after the scanning day is finished effectively, but also be able to start it up automatically before that next patient arrives the next day. So doing that, there's you know, effectively a 20% saving in energy. And again, we just talked around, you know, linking that to a smart buildings platform, rather than staff members having to remember to shut it down or scale it back. If the system is connected and working as one, the system should be intelligent enough to be able to shut that system down when the last patient's been scanned effectively. So looking at that, so again, trying to drive that automatically. Typically, I think these are estimates around what does that look like from a tangible savings point of view. So, and typically saving 20 megawatt hours a year, with sort of financial savings around 4,000 to 8,000 euros effectively. So. And there's an additional, which was a news to me, every day's a school day in Siemens. There is an eco power mode on most MRI scanners apparently now. From some of the surveys that the healthcare team has done, is not many trusts are aware of this. So again, switching it to that eco power mode, which doesn't shut the system down completely, but puts it into a standby mode, effectively, saves an additional 12% on energy. So all these things are out there. So again, we had to try and change a culture to get systems, like people trying to get people to turn lights off, I suppose. We had to change a culture to say, well, you know, drop it down to eco power mode or turn it off, or we make the systems more intelligent enough to be able to do that automatically without any human intervention. So combining them two, you know, there are some significant savings to be had there in energy consumption and obviously expenditure as well around running the MRI scanners. So you see that typically up to 30% saving if you combine the two, turning it off in non-use hours or drop it down to eco mode during in between scans effectively. So that, you know, produces quite significant financial savings, but also has a knock-on effective CO2 footprint as well. So I asked a question around what does the future look like? I'm not an expert in MRI scanners, but I don't profess to be. So there is something now, all our scanners come with, or all scanners should come with a decrease or an increased scan time effectively, so that actually what you're doing is what traditionally may have taken 30 minutes to scan a patient for a particular condition, through the more intelligent scanning process or a quicker scanning process, you actually save around 40% scan time in some of the new range scanners that are coming to the market. So there's two things around that. If you've got a reduced scan time of 20%, you've got reduced energy consumption. You can get more patients through in one day as well. So typically, if you're scanning 8 patients a day, but you're scanning them an hour at a time, you know, effectively you could scan another 2 patients that day as well if the system needs it. So, and again, that kind of drives efficiencies through time and running times and scanners, etc. So that's about it from me. Open to sort of any questions really. So Apologies for the croaky voice as well.
I just got a quick one on the scanners.
Yeah.
Can you actually turn them off? That cooling the magnet, so don't you have to leave your chilled water on to kill
I
them?
think it doesn't switch it off completely. So, like I said, I'm not 100% au
If you
fait
don't
with the
kill the
MRI.
magnet, then
Yeah.
you're not quenching, are you?
Yeah.
Quench.
So, I think it sort of it does say on one of the slips. Just bear with.
There's a footnote,
So,
wasn't it?
yeah, so one of the footnotes.
I can't see that.
No,
Bloody hell, some glasses.
I mean, just again,
There's a footnote
yeah.
there, turning off the system does not affect the magnetic field of the scanner, which remains its nominal strength.
Right.
Therefore, please continue to operate local MRI safety within the department. So there's I think it's about reduction, and it's just as you said, it's basic, just energy conservation, turn something off when it's not in use.
Yeah.
I think what's really interesting is the scalability of using what we would might think of a standalone PIR to control the lighting to feed back into a broader system.
Yeah, and I look at that and say, well, you know, PIR does one thing, it detects motion and it switches a switch. Let's make that a little bit more intelligent with an IoT sensor in the lighting system, which will look at motion detection, temperature monitoring as well, lighting levels, create a communications network. So
it's the deep, a faster scanning process.
that's effectively what we're saying. Yeah, so it reduces the
It's your system on time.
it reduces your system on time by up to 60%. And that obviously that's in the newer range of scanners that are coming into the market. I know there's scanners out there on a 15-year cycle, which will eventually be replaced by that reduced scan time. So
I think it's trying to get the trust operators of the systems to understand that saving is there, and you know, it probably needs to be approached from the two angles of, you know, us as designers of engineering,
absolutely, yeah,
and the operators of the system, because I know at one stage loads of theatres were not switched to night set,
and still are not today. Yeah,
and it's, you know, to me that always seemed to be such an easy win for energy conservation. So you know, you can get the imaging department to understand that is something you should be doing. You will help get your carbon targets down.
but again, I do think I agree with you, Steve. But there is a cultural shift that needs to happen within certain organisations, and that doesn't happen overnight. So you know,
No reason you couldn't shut your operating theatres down at night.
No.
And then have them on a time control.
Yeah.
And monitor the air quality in there.
Yeah.
Mm-hmm.
And know which time to turn it on, ready for the operation, so the theatre is right.
No, absolutely. Yeah.
So I mean that's simple to do, isn't it?
It is, yeah. But I think if you look at that from a
Really simple to do.
yeah, you know, it'll come on at a set time and it'll go off at a set time. Just if that feature is not being used during that day, it'll still come on and go off at that time. So kind of link a system back to a theatre schedule effectively.
Yeah.
So the system is sort of clever enough to know when that theatre is going to actually be used, and then it will start the systems up and check images, etc., etc. So
You've got all this, Chris, have you?
I wouldn't be allowed to have a direct protection start a hospital.
Yeah.
And you know, turn the theatres off at night, not night setback,
Yeah.
turn them off.
Yeah.
You would not believe the conversations that causes. And when you talk to infection control folks, you know, how many air changes in that theatre? 20 air changes. How many times do you think? How long do you think it takes to get clean air, if you like, not sterile, because it's been, and that's the kind of words you have to.
Well, theatre's not sterile anyway.
No,
So-
but I don't. But you could deal with the culture now.
Yeah.
That's on all the time. 20-25 hours. It's a bit like keep my MRI on, because actually I might get an emergency patient, and there's, you can't mess around with it. If they want an MRI, they need to get through the scanner. But most people have got two scanners, at least two MRIs.
Yeah.
So use that one as you see, turn it off, keep the magnet, you know, keep the magnet, etc. Just use it. But it's absolutely, it is a
it's cool.
you know, the startup time is 5 minutes in some scanners. So
I think it's a cultural thing, and also making people aware of what they've actually got, that they can do that. People are just fear of the.
The easy way to do what they do in America is they just run them all the time, and so you've got used to it. There's It's the Barrow Neurological Institute, and it's just by St Joseph's in Phoenix. And when I went there, and this is about 15 years ago now, they had 12 MRIs. And I thought, what? Like, and it was in like a great big horseshoe as it went out around the side, and they were sort of bad power and everything. And they put a new one on every year, virtually. And what they did at night, they do after, I think it's 7 o'clock when it closes, they do whole body scans of HMOs. So you go in there and you know, you have a whole body scan, so that finds if there's anything wrong with you, and it runs 24, you know, it runs all through the night.
Yep.
And on the back of that, they buy a new scanner every year.
Well, that's utilising the equipment, the medical intervention rather than in this situation.
But they make more money from that than they save on electricity.
Different model.
It's interesting that
It is. It's a different model of health.
talking to users about a 5-minute startup time, which I hadn't realised it was that quick. And I know when I've done energy efficiency studies, Halifax Hospital, and we got all the plants to operate in accordance with the hours that the departments would. So 80% of the hospital was 24/7, 20% was 9 to 5. We got the plants to operate in the same way that the departments, and we saved 10% energy within the first year, just by making that switch. But what I think is this was all just 20 odd years ago. So the actual intervention to do that change was a programmer knowing that system, and it was a locked protocol. Whereas now, as long as you got the Cat5 cable in the IoT compatible device, you've got the platform that you've talked about. Somebody with a reasonable level of intelligence and security, access control, and the levels of access controllability.
Absolutely, and I think that's part of the beauty of the smart hospital platforms, smart buildings platforms that are coming down the line. You know, there is constantly new applications and new smart apps being developed for different situations. You know, some of them are out of the box. Some of them you can sit down with a customer and say, well, let's work back from your problem. You know, how can we solve that problem? So you start off with the problem and try and work the system back and applications back to fix that and assist that problem effectively.
A bit of a view there. You've got any discrete system, but there's two things. It either has the functionality and it's not being used, or not being used, or it doesn't have the functionality. So let's say traditional BMS system, HVAC only, limited to that for the purposes of this conversation. And let's say it can't do something. Let's say it doesn't have time clock feature. Right. So then we add another system that gives it that time clock feature. I'm not convinced that's the right way to do it. I think probably discrete systems need to be adjusted to have that functionality, and then have a layer that brings it all together. You need to be very, I mean, you can do it. You can get, you know, let's say, one big system to manage it all and fill in all the gaps. But from an architecture point of view, someone needs to control that and say, okay, we can do it like that, or actually we fix it in the system that's responsible for managing that piece of plant and equipment. And then all we do is report that metric through to the next layer and allow access. Because otherwise, if you just went at it to give functionality, you'll have a bird's nest of different crossovers between different systems with no real plan. And that, I think, is the danger of it. Someone needs to be an architect of bringing a smart system together.
There needs to be
the right way.
solutions architects and MSI to integrate all the systems together. But I think you sort of touched on something there around control. And again, that's down to the end user to say, well, actually, I'm quite happy with my sort of independent BMS system, independent fire and security system, but I'd like the visibility of all them systems on one platform. And it's just them pulling data out, raw data out of them systems to be able to present it in a way which is useful.
And cohesive.
And cohesive, absolutely.
I think the benefit of having the sort of various standalone systems is that if you've got a smart building platform with everything on it and it goes over,
there is still, so even under that integration platform, you still got the conventional.
You can.
There is still very much them conventional layers, but I suppose in a conventional hospital, they all operate in silos effectively. They're used to silos a little bit.
Really important point. Having had that and having had failures because the network's gone down.
Yes, well, exactly. This is where I was at.
Right theatres, just to put that. stopped was technically, so I don't disagree with anything said. By the way, the big challenge is the integration of all these systems.
Yeah.
And actually, designers and facilities managers as well, because designers, I'll have a BMS system, I'll have an access control system, I'll have a fire alarm system. No, one system, do them all on one board. Yeah. You'll have a separate BMS, separate access control, like this, and this. Because all the specialists say, that's you've got to have ours does all this, and this. Then you have really struggled to get functionality and get them all, struggle to integrate them all.
Yeah.
They've all got these different interfaces, they do different things.
Yeah.
Then you have a CAFM system or CMMS system.
Yeah.
And then I've got a separate EME database, which its own RFID.
It's a huge
By the way, RFID tag, so I know exactly where the kit is.
Yeah.
But trying to input that information into the clinical system, to the PAS system patient.
Yeah.
Or EPR system.
Yeah. No, you're right.
It's a massive challenge. And you cannot, because everybody talks about digital twins, I have this debate with them all the time. What do you mean by that? I get a lot, sorry to say this, but I get a lot of people spout a lot of words, don't actually know
Absolutely. No, I'm with you on digital twins. It's
what it actually means when that really good graphic that you put up with all those things sort of
Yeah.
interfacing with one another. But it sounds so easy to do, and it is a massive challenge. Part of trying to get BMS to speak to fire, speak to security.
Yeah. And I get that, there is two sides to when you look at this. There is that, there's that legacy estate.
Well, that is the other.
Well, yes,
really,
that's a big one.
the legacy estate in this. I'm looking to upgrade my BMS system on one site alone, £700,000. Because I've got the first old generation controls. I've got to change all the controllers, all of the outstations, most of the field wire, just because it's so old.
Yeah.
That's just a massive amount of money.
It's incremental, isn't it? It's an incremental. You need a 5-10 year
And again,
master plan strategy to implement this sort of stuff, which is not always easy when you've got an annual capital spend to hit. And
To be frank, the BMS is on the list of critical infrastructure that I've got. It's
way down.
Yeah.
Yeah.
Don't get me wrong, there are opportunities like the NHP program.
Yeah. Because again, going
Yeah, it comes down to NHP.
What's the budget?
it's dead easy. You've got a blank piece of paper and you start
Yeah.
with nothing. Because you can do that. You can design it. Your design briefs, your digital strategies can implement all this.
The only good
But when you've got a legacy estate which has got chunks of this, chunks of that, and we're just trying to, you've got to start from somewhere, I suppose.
And given the cost of energy, cost of energy now been too cheap for too long. We all know that. Professional engineers have proved. Now it's probably the price where it makes investment.
Yeah.
Good driver for this kind of thing.
It's interesting that, because that never used to be the case.
Yeah, it was the last thing you looked at.
Yeah.
Big Frank.
We always had to hit the energy target, the 64 gigajoules as it was for many of the PFIs, then it dropped to
But it's
55 to 50.
54.9.
Yeah.
Almost 50.
What is it now though? And I don't know where it is.
I'll do it now.
It's disappeared.
It's gone. That's why the
Kilowatt.
opportunity for encode,
Yeah.
Richie was saying,
It's just
bringing the new metrics like TM54.
And I think there is a change in the market, not necessarily the healthcare market, but the as a service approach is becoming more and more prevalent in other sectors. So developers and investors and building tenants, in fact, or not so much tenants, but landlords are saying to us also, actually, I don't want the problem of owning all the assets and having to maintain them. Can I just pay you a service? A bit like the Sky subscription box. You own the asset, you maintain it. I pay you a subscription every month, every year to do that.
some of the
And
commercial.
Again, it's not quite the NHS or it's not
Yeah,
the healthcare sector. It's there is changes in the market, haven't they? Not see a little bit in the
One thing
UK.
I was going to ask before it goes out of my mind, it was about CAFM systems and BMS condition-based monitoring. Have you looked at anything that in this smart platform? So you're looking at monitoring the pump. And
Absolutely.
so if that one of those pumps down, it notifies the CAFM system, automatically generates a ticket, and the fitter can go out to.
Yeah. So I mean, again, through motor monitoring, through we can monitor vibration on the motor, we can monitor temperature rise and all that kind of stuff. And again, through that algorithm, trying to predict when that's going to fail.
Yeah.
You start to move into that category of preventative maintenance.
I think that's the condition-based maintenance is a big thing.
Mhm.
for smart hospitals.
Yeah.
Because there's not enough staff around. There's not enough
No.
staff around.
Yeah.
So having that condition-based monitoring, I think it's key.
Yeah.
And I think there's a big area of development in that.
And, as long as systems, I suppose, can talk to each other, you can write that algorithm to do that, to say, well, actually, I predict that based on historical trends of that motor, it's going to fail in a week's time or 2 weeks' time. So, again, take that a little bit further into producing that PO effectively for a replacement part. The system should, and there are systems out there that can do that. Will automatically order a spare part.
This is where it's probably a different way of thinking from traditional. So if you took current crop of controls point on, let's say, a pump station, that example, it wouldn't include points for VA, right? So, and that's just a conventional thing. That's because we haven't done it before. It's not that it couldn't. So what happens in this day and age is I guess, pardon the description, we come to a thing like this, we get a presentation on smart buildings and someone says, right, I need smart building solution for that application. And they'll go out, they'll speak to someone, and you'll get one of two things. It will be spectroscopic VA on a pump that's only got 2 bearings, right? So you don't really need it, but you'll get it once every 3 months from someone like SKF.
Yeah.
Right. Lots of money. And it means people come to site, control of contractors, stuff, extra work, not less work. And they get a report, and 12 months later, they've got 4 of them, and it looks okay, and pump still breaks down. It's still the same kind of breakdown. Or it gets integrated into a system like this. It's a new system, right? So to get the CapEx to finance this, to get that through a board, to get that, that's time as well.
Oh, absolutely.
When all it actually needed was a sensor connected to a traditional BMS point, right? That instead of picking up acceleration, goes through an amplifier, picks up 4 to 20 milliamps, and then you'll see a line rise over the course of 5 years, and you can go, okay, well, that's when it's going to fail, put a little cross there, and like a filter, it will just go into alarm. But then that system, as a visibility layer, not a layer doing the job, but insight into all those various systems, is hugely valuable, because then it's not just the guy on the shop floor looking at the pump, it's everyone. It's management. It could go get metrics from 50 hospitals and look at them and not buy that type of pump anymore in the NHS because they fail. That's where it needs to go. But it's not, it doesn't need another system to get there. What it needs is a change in specification at the design level. That's what it needs, in my opinion.
No, I completely agree. And again, the conventional approach of, yes, you can integrate all your fire and security into a BMS system, which is still needed. You still need all them independent systems in a smart hospital, but it's how you get them to communicate.
Unfortunately, I think the reality is, unless someone actually says this is how we're going to build a hospital, that probably won't happen.
I agree, absolutely.
Because it's extra, it's more money, and it's not actually required for compliance.
And there's no HTM for building control systems in England. There is in Scotland, but there isn't in England.
Right. Yeah. So, and there's ways of looking at it.
Yeah.
And I think, taking it right the way back to the start of the program, just understanding that return on investment is quite key. But it's getting someone to deliver against that as well. So,
it's that strategic short, medium-term plan that we talked about, Chris. What is it's not the priority, but what is the priority? If you're not getting penalised for not hitting an energy target, which you would be if you're a PFI operator, then,
Don't you think this all comes down to a true industrial strategy and smart cities and everything integrated and, transport systems?
ultimately, yeah. That's
It's come from government, industrial strategy going forward.
It's okay. You'll be retired by the time.
I will. No doubt about it.
But it's not.
But I think that, the hardest thing to do is to integrate legacy estates.
100%.
In every scheme that I've ever been involved in terms of PFI previously, and probably on NHP now, I guess, there is the easy bit is the new build. You can do everything you're offering there. In
Yep.
New build.
Yeah.
But then you've got someone has to make the decision. What do we do with the legacy estate? Because the legacy estate, the energy usage of the legacy estate could easily outweigh a modern building.
No, he's,
What
People do what?
Yeah. So someone, this is Department of Health or, individual trustees even have to take the decision that this is what we're going to do. And I honestly don't think anyone's going to do it because
I think to be fair, you have to also tell some clients as well. So your role of consultants in this room, sometimes I think actually is to push that message a bit.
yes,
If I'm honest, and I can sit there as, an asset manager, director of status, whatever you want to call me. And I should be forward thinking and I should be doing all these things. But what I do know is I'm doing that and many other things. And you deal with it in the culture as well. It's interesting to talk about culture. That's one of my team do vibration monitoring. I used to come from an industrial process background where you did proper CMMS, automotive. You have to do that shit.
Yeah.
Line going down, that's all for anything. Because you've got a production director.
There's a tangible link to it, a cost.
Down your absolute neck. Why is it off? You just cost me X thousands of pounds a minute type thing. You've also got, you're dealing with cultures as well, because most work states departments. I've had this debate with my team. And I keep saying, you've got to go away from a hammer that you've had to fix it to get that old pump working. And it's a bit of it's not, I don't mean disrespectfully, but I did say this, that you're going away from a hammer to hit it and get in the right place. Your first thing you'll be armed with is that thing there called a laptop.
Yeah. And interrogate it.
You say that to most today's team and they'll go, whoa, what's what? What does that mean? So there are all sorts of cultural challenges which
Yep.
can't ignore, but that's not to say that there can't be barriers that can be easily broken.
I mean, everyone knows if NHP goes down the route that it should be going, what will be handed over to you will be everything will be on a digital platform of some sort. Whereas traditionally, estates come FM operators in the old PFI word, they would be looking at, can I have a hard copy? Can I have a hard copy? Can I have a PDF? Because I don't want anything. I don't want anything like that.
Put all that in the cloud. Yeah.
And
Will you get that integration? Because if from a design point of view, this is one of my bugbears. From a design point of view, you get the design, and that goes if we do Reba Stage 4, then a contractor. There's no early integration to how it's going to be maintained with the CAPM system. What you're going to do with a Revit model is that going to be an as-fitted Revit model linked to the building management system as a digital twin? Is all that connected? And there's a big disconnect there.
There is.
So what you're going to get all these new hospitals, but you're never going to get that connection with it unless somebody sits here in the design stage who knows about the maintenance side of it.
yes,
And then
It's better to strip everything out from the Kobe files
No,
on the bin to give you your asset.
you need to
registered as
follow the
well.
government probably agency model of
Yeah.
cradle to grave,
Yeah.
which is which the NHS is probably not going to do. That's the GPA.
I'm doing it with the GPA at the moment.
Yeah, and that they made huge savings on all the HMRC work that came up, and that's now their national model. And Steve Barker's head of GPA now, I think, isn't he? Yeah. So that's where it's all going to go. But the one thing I was going to say, the real ability is actually money, because I mean the things that the forward-looking things that have been able to, and I did, was only because I had the money to do it. Put in a 38 degree C domestic hot water temperature circulation system. Sound Hospital in the country's got it. Big ammonia chillers. Sound Hospital in the country's got it. And it was because you could take the risk because I could pay the money. Didn't have to go for the cheapest option.
Mm-hmm.
There's legal compliance as well going to drive some of this stuff where you do have to have data, and all the monitoring and
record keeping, isn't it?
Record keeping, absolutely. Yeah.
I think the interesting thing is knowing the extent that the new digital platforms can go.
Yeah.
And what we talk, the light sensor as a prime example, the multi-factor things that could do for you, knowing that.
And I think in other markets we are seeing a change of approach as well to a more outcome-based contract approach.
Yeah.
So a customer's got a problem, and that problem might be I want to be net carbon zero by 2030. your problem. Do it for me, deliver it for me. But we contract against, well, you know, we contract against an outcome. And some other supplier takes that risk.
Exactly, we contract against the outcome.
Yeah.
So if you wanted bin level 7,
Fortunately,
pay us, we'll deliver bin level 7.
Mhm.
Yeah.
You'll get it.
yeah, but the problem with
That's not the contract.
The problem with all of this is the revenue to maintain these systems is not following the capital.
Yeah.
They're not going to fail. They are going to fail miserably because it might be able to say, okay, to say, right, Siemens or whoever going to take up my whole FM and do all this. Reality to organisations to do it before the revenue consequence to it.
Because that's why the GPA model works, because the data follows it all the way through and the information's there. So you get absolute spot on whole life costing. So you can't say, well, I'm going to buy that, but I'm not going to spend a penny on it, because you won't get the outcome you think.
Yeah, but you know how trust finances work. You've been there. I have. Every year my budget changes. It depends how hard the settlement is to the Treasury. Every year I don't get up to 3, 4, 5 years of that. NHS hasn't even got a long-term revenue strategy.
No, no, it hasn't.
Never mind capital strategy.
And it's completely broken as an idea of a wonderful proposition. Needs to
It's all-
change, isn't it?
It's not saying you shouldn't do the right thing.
Yeah. The can of worms from.
Before we get to.
Sorry.
A reality. Okay, well, I think enjoy that to a close. Thanks.
No problem.